students, welcome to today's session. In today's session we will start module 4. Actually in 4th module we will study database design and what are the measures you have to remember in designing a database. So first of all, in this session we will start an introduction to 4th module, that is an introduction to database design. So we know design of the relation schema decides its goodness, that is, if the relation schema has a good design, it will have a good quality. So design of a relation schema must be done very carefully. There are two approaches for database design. First one is bottom-up design methodology and top-down design methodology. Bottom-up design methodology is also known as design by synthesis. In bottom-up method, actually we will start from relationships among attributes. So first we will consider the relationships among attributes, then the related attributes will be combined to form a relation. That is bottom-up design methodology. Wherein top-down design methodology, which is also known as design by analysis, we will start with a number of attributes, then we will group the attributes into relations, then we will consider whether any relations are connected or whether there exists any relationship between relations, then the corresponding attributes will be represented by the relationship. That is top-down design methodology. So we can take any of the methodology to design a database. Whatever method you are using, the main aim of database design is reduce redundancy and preserve information. We know that from the beginning itself we are saying the same point. We have to reduce redundant data and we have to preserve information in a database. So first of all, we will study an informal guideline to design relational schemas. There are 4 guidelines we have to remember to design a relational schema. First one is semantics of attributes must be clear in a schema. Second one is reducing redundant information in tuple. Third one is reducing the null values in tuples. Fourth one, disallowing the possibility of generating spurious tuples. So we will see each one in detail. First one is imparting clear semantics to attributes in a relation. So we know when we group attributes to form a relation, the attributes must have a real world meaning and a proper interpretation associated with them. That is, you consider one example which is shown here, that is employee relation schema with attributes employee name, SSN of that employee, birth date of that employee, address of the employee and the department number of department in which that employee works. So here we can see all these attributes will have a clear semantics related to an employee. So this is how attributes should be grouped into relation. So when you group a number of attributes to form a relation, the attributes must be the property of that relation. Another example is shown here. Employee details with attributes employee name, SSN, birth date, address, department number. Along with that, one more attribute, department project numbers. Here department project numbers specifies the number of projects controlled by that department. So it's clear that department project number is not a property of employee. Actually it's a property of a department. So this is not a good method to collect attributes to form a relation. So when we collect attributes to form a relation, it should contain only the property of that real world object. That is the first point. So we should follow a guideline. Dear students, we have to study the guideline as such. Design a relational schema so that it is easy to explain its meaning. Do not combine attributes from multiple entity types and relationship types into a single relation. So we will see when this guideline is violated. Again, you consider an example, employee department, which stores the details of both employee and department. Attributes are employee name, SSN, birth date, address. These are the attributes of employee or properties of employee, and department number, department name, and manager SSN. So last three are the attributes of department. So here it's against the guideline, that is we have combined attributes of multiple entity types to form a single relation. Actually this table should be decomposed into two, employee and department, where employee table should contain employee name, SSN, birth date, address, and department number. Then department table should contain department name, department number, and department manager SSN. So this is an example of violating guideline 1. Now the second point, that is redundant information in tuples. So we know the main goal of using a database itself is to minimize redundancy or minimize storage space used by the relation. Consider the following examples. First table is employee department, which is a result of join operation of employee and department relations. We know when join operation is performed, the attributes with same name will be compared and both the tables will be joined. So here we can see this first table, employee department, will results in redundant information. So we will see when you store joins of base relations as another relation, it may cause insertion anomaly, deletion anomaly, and update anomalies. These are the drawbacks of storing join of base relations to form a new relation. We will see each one. First one is insertion anomaly. You consider the same example, employee department. Here, if you want to insert the details of an employee, we have to insert his department details also. That is, for each employee, we have to insert his department number, department name, and manager SSN. So when repetition comes, whenever you insert the details of each employee working in the same department, we are always entering the same department number, same department name, and same manager SSN. So that causes redundancy of data. Instead, if you store the department table as a different table and employee table contains only the details of employee, this repetition will not occur. So that is insertion anomaly. Similarly, if you want to insert the details of a department with no employees, so all the values of in that tuple, the values of employee name, SSN, birth date, and address will be null, because that department has no employee. So that is again, it's an insertion anomaly. That is not a good method of inserting a tuple. Now deletion anomaly is, suppose if you want to delete the details of a department or delete the details of the last employee in a department, then the details of that considered department also will be get deleted. So that again causes an anomaly, because we don't have any information regarding that particular department in that table. When we deleted the details of last employee in a department, the details of department also got deleted. So that is a drawback. That's called a deletion anomaly. Then modification anomaly occurs when, suppose in this example, if you want to change the manager SSN of a particular department, you have to make that change for all the tuples representing that same department. That is, for all employee tuples in that same department, you have to modify his manager SSN. Instead, if you store department as a different table, this change should be done in only a single tuple. that is modification anomaly. So here we can see, if you store the joined table as a different table, this may cause insertion anomaly, deletion anomaly and modification anomaly. So we have to remember a guideline: design a database relation schema so that no insertion, deletion or modification anomaly is present in a relation. If any anomaly exists, make sure that the application programs that update the database is operating correctly. Now the next point is null values in a tuple. We know that null value in a tuple doesn't mean that value is not there or value is 0. That is not the meaning. Null value has different interpretations. That is, that value may not be applicable to that tuple, or the value may be unknown. Then we will represent it by null values. So null value lead to problems with understanding the meaning of attributes. It's not clear what this null value represents. Also, it causes confusions in count and sum operations. Also, if null value comes in an attribute and if you perform select or join operation on that attribute, again the result may be wrong. So it's always better to avoid null values in tuples. So the guideline is, as far as possible, avoid placing attributes in a relation whose values may be frequently null. If nulls are unavoidable, make sure that they do not apply to majority of tuples. So the last point is generation of spurious tuples. We have already studied the concept of spurious tuples. Spurious tuples are generated in join operation or cross product. Actually, here we will consider three relations. First relation, employee project, which contains these many attributes, then employee location and employee project 1. Here, employee project table is decomposed into employee location and employee project 1. That is, from the employee project table, we have taken employee name and project location as a relation. Then rest of the attributes combine to form another relation. Here in employee location relation, both employee name and P location together forms the primary key. So independently or individually they may not be unique. Together they form the primary key. Wherein employee project 1, project number is the primary key. Spurious tuple occurs in join operation if we know that in join operation we will compare the attribute values of two relations. So if these joining attributes are not primary key, super key combinations, then spurious tuples will occur. That is, if you perform a join operation, in the joining condition we have to specify primary key of one table equal to foreign key of another table. You have to consider primary key and foreign key of two relations in the joining condition. Otherwise, definitely spurious tuples will occur. Spurious tuples means meaningless tuple or unwanted tuples. So here, if you perform the join of these two tables, we expect that we will get employee project table itself. That is, this table was a parent table. This is decomposed into these two tables. So obviously, when you join these two tables, we should get the parent table itself. But when you join employee location and employee project 1, there is no primary key super key combination to consider the joining condition. That is, if you combine these two tables, the joining condition will be P location is equal to P location in this table. So P location will be get compared. Here P location is not the primary key. Independently P location is not unique. Both E name and P location are together as the primary key. So here in joining condition we are not using a primary key super key combination. In that case, spurious tuples may occur. That is, that gives a wrong information in the database. So the guideline is design a relational schema so that they can be joined with equality conditions on attributes, and they are appropriately related a primary key foreign key pairs in such a way that it should not results in spurious tuples. So these 4 guidelines we have to remember in designing a relational schema. That is the first introduction to database design. Hope all of you understood the concept. Thank you. We will continue in the next session.